Balancing redox reactions, oxidation reduction reactions. These reactions are really useful, really powerful. In fact, they're what run alkaline batteries, and they're little sensors and bird brains. Electrochemistry is all over the place and really useful. One of the things that I really like about electrochem is space shuttle, right? It had liquid hydrogen and liquid oxygen, right? React them, and you go boom, right? Generate a lot of hot gas here. Very exothermic reaction. Hydrogen and oxygen probably combined to make what? Water. So it's pretty clean burning, right? So let me get some help here. Sarah, you're the lucky lady at the top of the list. Where's Sarah? Sarah, come on up here. I'm looking at Emily. Why do I keep looking at Emily whenever I see Sarah? Okay, so inside this balloon is 99.999, so they call it 5-9er. We use it for the GC upstairs. 5-9er hydrogen. So pure hydrogen's in this balloon. Sarah's just going to hold a little flame over it. It's going to burn through the rubber, right? Anything going to happen? Right? It should be rocket fuel. But isn't it missing a component? 99.999% hydrogen's in the balloon. Don't we need some oxygen? Where's the oxygen going to come from? The air. Yeah, air's like 21%. So try it, Sarah. So it's going to be loud. Hold it at the end. Sarah, hold it at the end. Back here. And just hold it at the bottom and burn through. Thank you, Sarah. So maybe you'll believe me when Smith says something. If a reaction's powerful, it's powerful. Whoop. So scientist dude number 1 says redox reactions they're really useful, but man, they can be really complex. So how are you going to balance them? How are you going to make predictions? Reactants products. Well, scientist number 2 says, hey, Smith has a game plan. Let's check it out. So here's my game plan. This sheet, feel free to tear it out when you go to the boards. Okay? So let's run through it step by step. But let's run through it step by step, this game plan and balancing redox reactions, actually balancing a redox reaction together. Okay? So I'm going to balance this redox reaction. It's a reaction where electrons are actually being exchanged between reactants. And it's going to be in basic solution. And it's nowhere near balanced now. The problem is that it's in water. And you've got, if it's basic, you can have a lot of hydrogen ions or hydroxide anions floating around. Hydroxides. So that's doesn't even show up. See how complex this is? So we're going to start, Lorena, with rule number 1. Split it into 2 half reactions. So Lorena, Cn minus probably goes to what product? CnO minus. Okay. And permanganate, Manuel, probably goes to MnO2. There's my 2 half reactions. Hey, not so bad, right? So for each half reaction, now I'm on step 2. That one's done. Step 2. For each half reaction, perform the following steps. Now this is what's important. You got to do this in order. Balance all atoms but O and H. So let's balance this first half reaction first. Balance all atoms, Stephen, but O and H. So that means balance the C's and balance the N's. Are they balanced? The C's and the N's? Yeah, they're balanced. Okay, so that's done. Next is balance O by adding H2O, right? Balance O by adding H2O molecules to the appropriate side. So are the O's balanced, Ashley? No. Ashley, I need to balance waters to what side? Reactants or products? Reactants. And how many?
One.
Just one. Right? Just add one H2O. Now the O's are balanced, Emily. Emily, but now balance the H's by adding H plus to the appropriate side. So add how many to the product? Two of them. And realize it's not two H's. It's 2H plus. Because, you know, acidic solutions have H pluses floating around. There's never any H's. You know, H exists as H2 gas. So it's either H plus or H2 gas. This is H plus by balancing H plus. So balance the H by adding H pluses. Done. Balance the charge by adding electrons to the appropriate side. Oh, Stephanie, this is the part that always gets everybody. And I don't know, it takes practice. The trick to do this, Stephanie, is take the coefficients and multiply them by the charge and add them up for both sides. So what's the coefficient in front of the H2O?
1.
It's a 1. And what is its charge? There's nothing written there, so it's got to be 0. So I have 1 times 0, everybody, which is 0. Okay, that one's 0. Plus, Connor, the cyanide. That total charge would be coefficient times the charge. You just get -1. So that's -1. Coefficient times the charge. The product side, Kendall.
That one would be
-1 and
then 2.
+2. Okay, so my whole side over here, I should have gave myself more space. My whole side on the product side, this whole side is going to be a +1. Does everybody agree? This whole side is -1. Okay, I have to, so the charge obviously isn't balanced. I got to get the same charge on both sides, and I can only do that by adding E minuses. Well, they're negatives, so all I can do is add negatives. So you're always going to add it to the more negative or the more positive side to get this thing balanced. More positive, right? So we have to add how many negatives to that product side? Let's just try it. Let's add 3. So we have a -3 and a +1 is a -2. Right? Because I have to add this and that. It doesn't work. So how many E negatives? 2 of them. A -2 and a +1 would give me -1. I'm done. Okay. Let's balance. So let's clean this up. And let's balance. Let's balance the second half reaction now. Okay, so for each half reaction, we're supposed to do these steps. So first, we're supposed to balance all atoms but O and H. So Kenneth, is that first step done? Balance all atoms but O and H? Yeah, it's done. Mn and Mn. There's our manganese. So Audrey, balance O by adding H2O. Right? You go on the product side. Yes. Right? We're short how many O's? 2 of them. So we have to add 2 H2Os. Right? Because now I've got 4 oxygens on both sides. Done. Great. That step is done. Now balance the H's by adding H pluses. So Sydney, how would you do this one? Balance the H's by adding H pluses. Add it to the reactant side. How many of them? 4 of them. Good deal. Okay. Now that charge mess. We got two sides. Paul, on this reactant side, multiply the coefficient times the charge for each compound and add it up. What do you get? You get 4 times positive 1. You get a positive 4 here. Positive 4 and negative 1. So the total would be right? Positive 4, so there's like 4 minus 1, so just be 3. Good deal. So this side's 3. How about the product side, Giselle? Multiply the coefficients times the charges and add them up.
Would be 1
1 times, what's the charge here?
Oh, it's 0.
0. So really you have 0
And 0.
and 0. Okay, we have to add, so it's a lot of work, this step. Getting those charges the same on both sides. Definitely not the same. Add electrons to the most positive side, Mia. How many? Add 3 to the most positive side. Reactants or products? Reactants. Exactly, it's the most positive side. Add 3 of them. Okay, now there's some hints that let you know whether you're doing this right in the first place. All these redox reactions, every single one of them involves adding electrons. But you can't have electrons floating around. This is the whole idea. This top reaction, half reaction, is producing electrons. The bottom half reaction is sucking them up to proceed. So the electrons produced has to equal the electrons consumed, so they have to cancel out. So, and you can't cancel anything out unless you have electrons on both sides. So that's a hint to whether you're doing this right or not. When you're doing this right, you better have electrons on both sides so you can cancel them out. Now, it may not be the most, Tanya, might not be the straightest, most straightforward thing to cancel these out, but it can be done. We'll multiply the top one by what and the bottom one by what. So when we add up these reactions, this will work. Multiply the top one by 3 and the bottom one by 2. Okay. Does everybody see why? Right? Because I'll have 3 times, where am I? Here it is, 2. So I'll have 6 electrons here. 2 times 3, 6 electrons here. Now when we go to the boards, what folks like to do, they like to rewrite this. But you don't need to. Definitely do not. Because it's going to be so much writing, and the odds are you're going to transpose something wrong, and then you just, all this work that takes you 10 minutes is just a waste. And plus it's faster if you don't rewrite it. So what I'm saying is you write your arrow, you see how nice I have my arrows lined up? I'm going to multiply these guys through by 3 and write my result. Multiply the bottom one by 2 and write my result. And do the same on the other side. So I have 3 H2Os plus 3 cyanides, and 2 times 4 is 8 hydrogen ions, and 2 permanganates. Now I do the same for the product side. Right? 3 times the top row plus 2 times the bottom row. 3 CNO minuses, 6 hydrogen ions, and 2 MnO2s, and 4 waters. Okay. Now you could have even saved yourself some more time. Do you notice? Because we canceled the electrons, well, why don't we just cancel other stuff too? We would have really cleaned this up, our final answer. But you can either do it this way or up top, do a little bit more work. You'd recognize, oh, I have waters here and I have waters here. You could have done the canceling up here. But this is fine. We're just doing it our first time, so if you want to write it out this way, it kind of helps me from screwing up. Okay, so now we got to simplify it. Because we've got waters on both sides. So can I cancel all 3 of these? Yeah, I can, right? Because I've got 4 over here. So let's change that 4 to a 1. And cross all of those out. They're all gone. Can I cancel anything else, Alyssa? Can I cancel anything else? Cancel what? But then I need to have M and O2s on this side, and I don't. There is something in there. Can you see it? The H pluses. Okay. So which one is smaller? I have the 8 and the 6. So cancel all of these. Make the 8 a 2. Okay. Now you can go out and make this a lot prettier and rewrite it. Okay. In fact, I would, if the solution didn't say basic, if it said acidic. If it said acidic, you know, I'd be nice to Dr. Smith and I would rewrite this thing so it all looks nice and pretty, right? But this is really pretty clear. You don't really, if you're this neat, I don't think you need to worry about it. But it doesn't say acidic. So if it said acidic, we could quit. But it says basic. So where we're at in this is, so we added the 2 half reactions and we canceled common species. That's done. Check to see if it's simplified. Okay. Oh, check to see if it's balanced. Usually all I do is check the oxygens on both sides. If the oxygens are good, because that's the most complicated one, if the oxygens are good, I bet I'm done. I'm balanced anyway. So on this entire reactant side, how many oxygens do you see? 2 times 4. I've got 8. Remember, all these were gone. So all I have is 2 times 4. All I have is 8 oxygens. 8 oxygens on that side. How about on the product side? Right? It's hard to see, isn't it? 3 plus 4 plus 1. Right? It's hard to see. 8 O's. So they're balanced. Okay? So this is good. So we checked to see if it was balanced and all good. If it said acidic, it doesn't. But if it did, you could quit. Draw a box around your answer, probably clean it up because it's an ugly mess. Okay, but we're in basic solution. So in basic solution, there's one last step. Convert all the H pluses to water by adding an appropriate number of hydroxides to each side. So this is nice and balanced. So whatever you do to one side, you have to do to the other side. Okay. So where do you see H pluses here, Sarah? Where do you see H pluses? Where do you see H pluses? Do you see any H pluses at all to convert? Yeah, there's 2 of them on the reactant side. So if there's 2 of them, we better add how many hydroxides? Well, let's just clean this up to make it easier. 3Cn minus, 2H plus, 2 permanganates, 3CnO minus, 2 MnO2, and water. Okay, I just rewrote it so it'll look better. Now, Sarah said there's 2 of them. She's right. So I have to add how many hydroxides to both sides? Remember, H plus and only 1 OH minus makes water. So if I have 2 H pluses, I better add 2 OH minuses, so now I'll get 2 waters. So let's add 2 OH minuses. Make sure you do that to the other side. Okay. And what I like to do is I like to do this. I like to, otherwise I just end up screwing up after all this work. So I actually physically write 2 OH minuses to both sides. Then I'm going to circle this. You don't have to do it this way. This is how I do it. And then I cross it out, and I write how many waters? 2 of them. Okay, so I'm really done. Oh no, I'm not done, because now how can I simplify this, Giselle? It's not simplified. Yeah, I've got a water on the product side. So I'm going to have to rewrite this again. Cross this water out, make the 2 a 1. All right, now I should definitely rewrite this. This is getting ugly. So my final answer, 3 cyanides plus water plus 2 permanganates gives 3 of these cyanide complexes plus 2 manganese 4 oxides and 2 OH, 2 hydroxides. There's my final answer. Okay. So what we just went through is probably the hardest type of problem you're going to see. Okay. It had everything in it. Now I wanted to make sure we went through the hardest type. Okay. So any questions on any of these little steps? So what's important is to follow this handout. And you're going to follow that handout so many times in doing the homework, you'll be comfortable, you'll have it down. Okay? So at first you'll be looking at it, but after a while you won't need it. And just make sure you do things in the right order. And the most common mistake is getting those charges, right? Adding up the charges on both sides. Remember, the trick is just multiply the coefficient times the charge and add them up. And then add electrons to the most positive side. So let's go to the boards and try this first one. It's not basic, it's acidic, thank goodness. We have nitrate plus copper gives NO plus copper 2. And you can I'd bring your hand out. Oh, sorry. Oh, whack. Nitrate plus copper gives NO plus copper 2. So remember the first step, break it into its half reactions, right? Enrique, there's room over there by Paul if you want to work by Paul. Okay. Kenneth, what's up?
The side doesn't have any of the O or H's. You just go straight to the charge part.
Yeah, I just skipped that step.
Okay, thanks, sir.
Yeah.
You asked me when you said balance all of them.
Yeah, balance
So-
everything but O and H.
Okay, so we wouldn't balance these.
So ends are done.
And
Everything
then-
but O and H.
Oh, okay, so then these are good too.
And then you balance the O's.
Okay.
And there's no O's to balance here. This is an easy one.
Okay.
But this one, there's O's to balance.
Okay.
Right. So split it into its half reactions. Then balance everything but O and H. Then O's by adding H2O. H's by adding H plus. Electrons to the most positive side. And do that for each half reaction. So if you're not sure, just ask.
On this one? Okay, now, I think that's the correct answer, right? With the,
Because this is 1 times a negative 1. It has a negative 1. So
Oh,
one
it's a
that's a
negative.
negative 1.
Oh.
So it's a 3.
It had to be a positive 3. Right? Don't forget to write your plus. Because when you do those charges, you're going to be able, you need that.
-1. And then. Oh my God,
Okay, you got zeros. This side is going to be a negative 1. What? You have,
That's a negative, right?
oh, I see. But you have a 2 here. 2 times 2 is 4. So that, there you go. Yep.
Do you get the E's first and then you balance them, right?
You first you balance everything but O and H, and then you balance the O's by adding H to O. You balance the H's by adding H plus.
Yeah.
So
I have to go in.
N's are done, and now you have 3 O's. So now you've got only 2 O's. You need 1 more, put a 2 there.
Okay. And
Now
that
you-
makes it 4 A's.
There you go. Yep.
Over here.
Now you got to do charge.
Now you do the charge. Okay.
Yep.
So then how do you cancel the electrons right here? So if
Well, you haven't done this one yet.
okay. But how do you?
This one's gonna be easy.
Oxygen, hydrogen, then-
Yes, you can skip it.
Okay.
You go right to the charge.
Okay.
O's and H's are balanced. Right to the charge. Yeah, they're, so when you did this, NO3 minus, right, has to go to NO. Cu has to go to, whoa, what is, so when you, oh, you wrote the whole answer here. This is just the problem is what you're doing, right? Is that what you're doing?
Yeah.
Okay, this is the entire problem. So Cu goes to Cu plus 2. So that takes care of those 2. Now this one goes to that one. Those are your 2 half reactions. That's step 1. And then,
You add the H to the.
well, there are no H2Os here. So Cu is done, but you have to do the charge yet. Add electrons to the most positive side. So what side's the most positive? This one. So add how many electrons? 2 of them. Because then you have 0 equals 0. So this side's done. Now you got to do this one. So that copper half reaction is pretty straightforward, right? There's nothing to balance there except the charges. So you make 0 on both sides by adding 2 electrons to the copper. However, the nitrate, a little more work.
If the two coppers have different charges, you can't cancel them out, right?
That's not the same thing.
Okay, good.
So hopefully you're adding 2 electrons to the copper half reaction and 3 to the nitrate half reaction. That's how it should be working out. You're doing it right if you're adding them up that way. Then you have to multiply. Good. You're going to be canceling 6 electrons. Yeah. Okay, so do follow the steps. So everything but O and H, done. It's copper. Balance O's, see, there's no O's. Balance H, there's no H, done. Balance the charge by adding E minuses to the most positive side. So you have a 2 on that side and 0 on that side. So add them to that side. Add 2 of them. Because then you'd have a 0 on both sides. If it's acidic, you're done. You can just check to make sure it's balanced. See if the O's, see if you can cancel anything, you missed it. See if the O's are balanced on both sides, and then you're done.
You went this, and this on the same side.
Yeah, good. Yeah, that's right. Boom, all that goes down here, and all this, exactly.
On the opposite side?
Yep, because of the arrows.
Okay.
Let's write it up here and see. 2 times 3 is 6. So I got my final answer. I have 6 oxygens on both sides, so I think that should be right. So for A, yeah, it's because it said acidic, so quit. Yeah, if you can check your oxygens and make sure you should have 6 on both sides. Okay. So if you and the folks around you got this, just go on to the next one. If not, let me help you out.
You don't have to cancel the 3 Cu.
Oh, you can't because one is Cu, the other one's Cu plus 2. This is copper dissolved in water. The other one is just solid. We're already getting lazy. We should be writing subscripts, S and AQ, but, right? It's just getting lazy.
Is it just for all the H's or just for the H here?
I have to add up all the H's on one side, have to be equal to all the H's on the other side. Now you've got a basic one. B is a basic one. So now you have to get your answer in acidic solution, and then you convert all the H's to H pluses to water by adding hydroxide to both sides. So B has an extra step. So first step, break it into its half reactions. Then for each half reaction, balance everything but O and H. Then O's by adding H2O, H's by adding H+. Then charge by adding electrons to the most positive side. Everything but O and H. So N's are done.
And then these are done too.
I would just do all of my, I just kind of like to finish this one before I go on and do that one. I think it's faster.
Okay.
Do all the steps on this one, then do all the steps on this one.
Okay.
I think it's faster.
That'll help me not get confused on
I think it helps. So zinc is done, and then you do O's by adding H2O. So you have 4 O's, so 4 H2O's.
Okay.
And then the H's.
So the next step is to have the 4
Yeah,
O's, so then we put, because the O's are on this side, right?
yeah.
Okay.
Now you've got 4 O's on both sides. O's are done.
And
Then H's by adding H+.
so there's 4 H's here.
But not enough, because here you've got 8.
H is over 8. So then
There you go. Yep. So I think it's good practice to wrap up one half reaction before you do the next one. So oh, but don't forget you have 4 with the zinc hydroxide compound. So I only need 4 over there. Yes, because you have 4 O's here. So you got to get 4 O's over there. The only way is by adding H2O. Okay.
To balance the.
Now the H's.
Now you have
8. But here you have 4, but it's not enough.
add 4H.
4 more. Now the H's are done. Good. Now you got to do the charge. The coefficients times the charge.
All of this -2?
I think it's supposed to be a negative. Yeah, it is a -2.
This is
Negative 2.
OH is on
This
the
whole
other.
thing is a -2. So the coefficient is a 1 times a -2. -2. And then, oh, you didn't add enough. You said 4 of them. Yeah.
Don't we add the 2e to the other side?
That whole side is going to be +2. This whole side is +2. No, just write it somewhere. That whole side is +2. That whole side is 0. Yeah.
So I have to put
Yeah, how many? There you go. Good. Kendall, you had a question?
When I look at it, oh, never mind.
Yep.
How did it know where to add the H2O?
Because that's the only way to balance O's. I've got 4 O's here, and I've got none here. So I have to add 4 O's to the side, 4 H2O's.
Oh, so here I have to add.
Now, but do one, finish one before you go on to the next one.
Okay.
It's easier, believe me. Okay, so now you've got, the O's are done, now you do the H's. I've got 8 H's, 4 H's. Not enough H's on this side. I need 4 more. So H pluses. Yeah, now you do the charge. So over here I got 4 times 0 plus 1 times 0. This whole side is 0. This whole side is 1 times a -2 plus 4 times a +1.
So that's -4.
So the total would be
+4.
positive, well, 4 and a -2, +2. So now you add electrons to the most positive side.
So it would be +2.
2 of them. There you go. This whole thing is done. Now you do the same thing for this one and finish it. Well-
Which one is the preload?
Oh, it's in the schedule. Let's see, this whole side.
Because the last thing you did was investigation 3. Oh, we're on investigation 4, but still. I think there's like one thing you have to do.
Last one we did was in the back of the book.
Yeah, so I don't know if she's going to order that. It depends.
Yes, we're going in order. We're following that schedule.
Oh, we are? Okay, good.
We haven't gone away from it.
Wow, it's already 10:49. Do we just pack up, sir? This is a minute.
So, Kenneth, that's not helpful. Okay, now did you, so for this let's see, you add 2 electrons for the zinc to the product side, and hopefully 8 electrons to the reactant side, right, for the nitrate half reaction. Multiply the top one through by 4, right, so those will cancel. Right. Okay. Because I need 8 electrons to cancel. Right? So I multiply the bottom one through by 1, which is really nothing. Just leave it alone. But the top one has to be times 4, so those electrons will cancel out. Okay? So I'll have 16 waters, 4 zincs, 9 hydrogen ions, and a nitrate. So there's my answer for acidic solution. That's my answer for acidic solution. I'll end up adding 7 hydroxides to both sides to make it basic. Okay. So this whole thing would be 7 waters. All right. And that would cancel with this and make a 6. So I'd definitely rewrite that answer, but that's it. I can rewrite it.
When was the last?
Check the schedule. Have a good day. So there's my answer. That's long. Those basic ones are long.
My test for Friday doing community art.
Yeah. Today? Yeah. Just come by.
Thank you.